Hi Year 10s, welcome back. We're moving on to summary statistics today, which is exercise 9C. Now your learning intentions for today is to learn, or perhaps to remember, some of you might be a review, how to find summary statistics for a set of data. And this is so that the data becomes easier to interpret and compare. So to be successful at this, you've got to be able to work out the 5-number summary, and you're going to be able to use that 5-number summary to work out the range, the interquartile range, and then to be able to determine if the data set has an outlier using a special formula to calculate the upper and lower fences. Ultimately, you're going to take these skills to work out these 5-number summaries to making box plots in exercise 9D. Let's start with the 5-number summary. Now, 5-number summary is your minimum, your maximum, your median, your first quartile, and your third quartile. So the minimum is the lowest number. The maximum is the highest number. Median is the middle number. And then there's first quartile and third quartile. Well, the first quartile is the number that is 1/4 of the way through the sequence, because you're going to have to write all the numbers in the data set in order from smallest to highest to do this. And the third quartile is the number is 3/4 of the way through the sequence. So let's get a data set and see how this works. All right, so I'll use this data set of 14 numbers. Now my first step is I'm going to have to write them in order. All right, there we go. So that's that in order. I've also double checked that I had 14 numbers here and I've got 14 numbers again here, just to make sure I don't accidentally leave any out. Okay, the next step is we need to find the median. Now you can do this one of two ways. For both ways, you need to recognize that the number of scores is 14. That's what n equals 14 means. Now, if you're going to do it with a formula, the position of your median can be found out by using n plus 1 divided by 2. So that's 15, because 14 plus 1 is 15, which is 15 divided by 2, which is 7.5. Now what that means is you need to go up to your number line and figure out where position 7 is. So 1, 2, 3, 4, 5, 6, 7, which means that's the 8th position, and the median is going to sit right in the middle. Oh, I've lost my position there. Okay, so that's where the median is going to be. Now both of them are 5, so that means your median is 5. Because what you're doing is you're finding the average of the 7th and 8th number. The 7th number is 5, the 8th number is 5, divided by 2, it's 10 divided by 2, so it's 5. Probably really didn't need to do that working out, but I just wanted to demonstrate how it's done. You can see that I've just basically split the data in 5, and there's 7 points before the split and 7 points after the split. So you don't necessarily have to use this formula to find this median. You can just literally count however many numbers in until you meet in the middle. It's not very mathematically sound, but it works. Okay, so now we've got our median and we've split the data into half. Now we have to find the quartile position. What you need to think of is that the quartile position is basically the first half of the data split in half. And if you think you've got 1, 2, 3, 4, 5, 6, 7 numbers, if you come in and meet at the middle, so count off the first 3, count off the last 3, you end up at 5. That's actually going to be our first quartile. And likewise for the second half of the data. So the first 3, the last 3 leaves us at 6. Another way to find the quartile position is to use the same formula as we used up here. This time we're letting n equal 7, and we're looking for the quartile position, but it's still n plus 1 divided by 2, which is 7 plus 1, which is 8, divided by 2 is the 4th position. So you go back to your numbers, and you go 1, 2, 3, 4. First quartile is 5. And to find the third quartile, you count from the median, 1, 2, 3, 4. The third quartile is 6. So currently we've got 3 of our 5-number summary. We've got that our median is 5, and our first quartile is 5, and our third quartile is 6. And you can write first quartile as Q1 and third quartile as Q3. Fun fact, you can also write the median as Q2. But I want a 5-number summary. So the fourth and fifth number is made up by the smallest number, which is right here, it's 2, and the largest number, which is 8. So let's write that out. And to do that, all you do is just write them in sequence. Minimum is 2, quartile 1 is 5, median is 6, quartile 3 is 6, and maximum is 8. So now we have a 5-number summary, and we can use that to find a few more details. Let's start with the range and the interquartile range. Now, before I show you how to do that, I just want to draw your attention to the fact that there are very useful ways to compare the spread of data. A bigger range would indicate a wider spread. So if you want to compare if something is more reliable, for example, you'd be looking for a smaller spread because you'd want to be hitting close to a certain value more often. But if variability is desirable, then a wider spread is a good thing. Let's get into it. The range is simply the maximum number minus the minimum number, which is going to be 8 minus 2. And 8 minus 2 is 6. So we've got a range of 6. The IQR, or the interquartile range, is the range that sits in between the two quarters. So the interquartile tells you that's in between the two quartiles that we worked out. So it's Q3 minus Q1, which is, what was Q3, was 6, minus 5, that's a really hard sum. The interquartile range is 1. That's a tiny interquartile range, and that means that there was a lot of reliability in the original data. If you look at it, there was a lot of 5s, 7 5s, half the data was 5. Okay, the final thing mathematically, for drawing box plots or anything like that, that you might have to do with a 5-number summary is work out the fences and then identify if there's any outliers. To work out the fences, you're going to use these formulas, and if you look at them, there's a lower fence and an upper fence, and the formulas are very similar. They both use 1.5 times the interquartile range, but in one case, to work out the lower fence, you're subtracting it from the first quartile, and to work out the upper fence, you're adding it to the third quartile. So these fences are going to fit somewhere between the minimum and the first quartile, and the upper fence and the maximum. Okay, so let's substitute our values. Instead of Q1, it's going to be 5, because our first quartile was 5, minus 1.5 times the interquartile range, which is 1. There we go. So 5 minus 1.5 times 1, it's 5 minus 1.5, so it's going to be 3.5. Now we're going to do the same to our upper fence. Sorry, I just reorganized things a little bit. So the upper fence is Q3 plus 1.5 times the IQR. Q3 was 6. So let's substitute that. We leave the 1.5 and we substitute the IQR is just 1. So 6 plus 1.5 times 1. 1.5 times 1 is 1. So it's 6 plus 1.5, which is 7. That's a lower fence of 3.5 and an upper fence of 7. So now what we need to do is go back to our original data and see if there's anything above and below that value. And we can see that there's going to be a fence here because the lower fence was 3.5, so that means 2 is an outlier. And the upper fence was 7.5, which means 8's an outlier. So you just list your outliers down the bottom, 2 and 8. And you're done. That's all you need to do with the data for this particular exercise and with the 5-number summary. As I said earlier, next lesson, which I think is after the school holidays, you're going to be using this information to make box and whisker plots. Alrighty, so you should now be able to work out the 5-number summary and use that summary to find range, interquartile range, and outliers. All right, thank you guys.